Well, hi everybody, and welcome to the next session. Obviously, you can recognize him already from his slide. This speaker is Steef-Jan Wiggers, and he is another speaker with a firm footprint in the Microsoft integration community, and also as a speaker at Integrate. Well, actually, you were one of the very first ones, right? Together with some other people of the crew. Microsoft has rewarded him for his efforts by giving him the MVP title for 10 years in a row now. Today, Steef-Jan will introduce us to the Microsoft offerings in artificial intelligence and machine learning, integration and monitoring. So please, Steef-Jan, go ahead. The floor is yours.
Okay, thank you. Hi everyone. It's beautiful weather outside. I just strolled with my wife and the dogs before we started this session. I also, as you can see, wear matching shirts for this event, so it kind of calls up really nicely. I'm going to talk about artificial intelligence, machine learning, integration, and monitoring, and how these all, are holistically connected or combined to each other or correlate to each other. So a little bit about myself. Okay, I work for Codit. I think many of you know Codit, one of the sponsors of this event as well. So I work there as an Azure technology consultant. I'm a Microsoft MVP, as told, for the last 10 years. BizTalk, integration, now it's Azure focused. I write for InfoQ, so predominantly, if you're familiar with the platform, different cloud technologies, languages, etc. Also content writer for Service Notes, and besides participating in an Azure Dutch user group, I also organize events which is called Azure Lotion. So full breadth of stuff I do for the community. And besides, and you're probably aware if you've seen my session before, the thing I usually like to do is running. So that's what you see on the left-hand side. That's kind of, in a nutshell, who I am. And let's dive into the agenda. So I'll talk a bit about data-driven solutions, machine learning, artificial intelligence, Azure, and monitoring. So those combined, those are the kind of 4 topics in this talk, and they kind of have a relation to each other, some scenarios and demos. Okay, so we're heading towards a data-driven economy, if you might have not noticed already, because let's say you got a mobile phone and sometimes you're not aware of the fact that you've enabled tracking. So you're already effectively being monitored, right? And they kind of track where you're going and they're using that data. But going back all the way back to, let's do a history lesson and go all the way back to before Christ. So the beginning of the economies were more driven around land, right? So we were getter-scatter hunters, and then we start doing more agriculture and stuff. And then land became more important with driving up economy, or even conquering land, or even exploring lands. And then going forward, when land was abundant, and or at least abundantly available, but people were less necessary because it was more efficient to work the land, then they became more evolved in as a workforce for the industrial revolution, basically. So that's happened the 19th and 20th century, and then going forward, we kind of get to know Industry 2.0, which all had to do with internet, and then going forward with the cloud. And you have to do with kind of the capital is driving the economy, right? With web shops and all that kind of stuff. And now today it's all about data. So that's where it's gearing towards, right? So this is what the economy is basically going forward to. So this means that even might already doing this, or potentially in the future are focusing more on data-driven solutions, if not already. If you're working within integration, you're already dealing with data, but then the data has a different type of purpose, because you're actually going to work with the data as well, providing you insights, or maybe you drive to a different kind of business, or you're taking different time of decision. And using your data, or at least gathering the data and using it for certain purposes, really helps you differentiate from at least your business or your customer's business towards other business, because then data is the heart of your solution. So you basically get a whole data economy, Internet of Things, which is already present and which is a kind of a driver for our AI, economy of today as well. You're getting more modernization within your business applications, and you're also going to get more bespoke type of solutions within predominantly now EC and healthcare. And I'll get to that later as well. But this is kind of, where things are gearing towards. So that said, let's look at some of the stuff. So I'm not going to go in depth what machine learning is, but I kind of want to talk a little bit one-on-one. If you're not really familiar with what machine learning is, probably most of you are programmers or have done programming. So traditionally, it's kind of you put in data and some of the rules, and then you get answers. At least it provides you with some answers. And then if you look at machine learning, it's a bit different, because on the forehand, you're already giving kind of the outcome or answers and data, feed it into machine learning, and then it gives you something different back, kind of rules which enable you to do predictions in the future, for instance. So you can apply those rules on models and everything. So that's kind of in a nutshell what machine learning is. And the best way to explain a little bit is maybe with something like activity recognition, right? So you have your data, you have your rules, and you kind of see it programmed out here, right? A certain speed, you're walking, then, you know, if you increase your speed, potentially you're running. If you increase your speed furthermore, you might even be cycling, depending on the rules you apply, and then, oh, golfing, that's something different, right? So if you already feed in your answers like, okay, this is walking, and you kind of label this, same as with running and biking and golfing, then you're basically better in differentiating something what, you know, your activity is versus your traditional programming. So that said, kind of, you know, Microsoft and many of the other cloud platforms provide, you know, tooling for it. So within Azure, you got a kind of a visual designer. It's got support for R scripts, which overall you find in many platforms to basically clean your data and that kind of stuff. For instance, you can also use Python for, which is also across the board and supported on multiple cloud platforms. There's open source platforms. So there's kind of a lot of stuff that, you know, Microsoft and the other cloud vendors kind of offer. So I'm trying to give you a scenario here with regards to, let's say, machine learning. So what we've done within Coded, we've kind of, you know, did this experiment where we went to a device provider, or at least manufacturer. So there are many out there. And in this case, we call for Yanzi, and they were able to provide, or at least we bought those devices. So an instrument basically our office space. So we got a meeting room, we got an office space and general manager. We got a kind of small branch office in the Netherlands, as we are represented in multiple countries. Belgium is the head office. This is our smaller office. And we provision that with devices that can measure temperature, humidity, CO2 movement, and kind of stuff. So different devices measuring different types of telemetry. Some provide more, some provide less telemetry, basically. And what we kind of did, so this is behind the scenes in that office space, that those Yanzi devices are connected to a gateway, which pushes that telemetry out, which we basically gather through a function. So from a timely base, we go to this gateway, say, okay, give me all that data, and push that through IoT Hub. So that's kind of our telemetry buffer through a stream analytics job. Feed that into a dashboard, so you can kind of near real-time-ish monitoring, but also feed that into blob storage to do potentially machine learning experiments with that. So, and that's what we actually done. So one way what you see here is the smart building dashboard. So you see the office space, you see some of the detections going on, some of the temperatures, humidity, illumination, and that kind of stuff. So this is kind of what's being fed into our dashboard. And this is something we actually have in our office on a device. So we have a small Samsung device which basically displays this dashboard. It's pretty neat. On the other hand, we also did, invite for machine learning experiments. So I'm not a data scientist, but fortunately we do have people that have studied some of the data science. So they get that data from that storage account, CSV type of data. They apply some transforming tasks. They use some of the data. This is what you usually do in your model. Some of the percentage of your data set or your data you use for training, and some of that data set you're using to test your model, basically. So what he took one of the models, at least the data scientist did. He used what's called a boosted decision tree, using the range of all these kind of parameters, so humidity, temperature, etc. Score the model, because that's what you do. You do your experiment, you score your model, and export the results. And you get something like this. It's not really a clearish picture. It's kind of light gray, but it's basically predicts the scored labels, the scored humidity versus the actual humidity. So based on some of the parameters like CO2 levels and temperatures, kind of predicts what the humidity level should be, or at least could have been, because boosted decision tree is something like what's called supervised learning. So it's kind of, you already know the actual data you feed in, and based on certain rules you apply to in that model. So the model is something you can choose within a machine learning model. So there's tons of models out there that you can leverage, and then you just have to feed some parameters in and configure those, and then you can get these type of results. So something really fun to do is basically you gather your data based on monitoring what's happening in your office with CO2, presence, etc. So in a nutshell, machine learning is something that you really can be useful, even from an integration standpoint, that you might even gather some of the data towards storage in this case. So basically set up the ingestion to get data into storage. But the thing in general, once you start applying on that data, is that, depending on how much data it is, it drives your technology choice. So the way if you're storing the data, the way of ingestion, but also the way you're going to work with the data based on what kind of machine learning model. The thing though you have to think about though, and considerations are bias, so that can easily be in, so you're overarching your model or you're doing some type of correlation, which you shouldn't. So bias is something you have to think about as well. And the other thing is privacy and regulation, of course, because you're using sometimes data from people itself. So that's something you have to think about as well. And then in the end, you know, machine learning can be fun, it can be interesting for you, even from an integration standpoint, but always look at that there should be a business case and you should add some value, right? Experimenting is always fine, but even if you show in the case in our office, eventually you want to drive to a certain use case. It could be like office occupants and stuff. So if there are too many people in your office, it might not be good for your environment with CO2 levels, etc. So this could be a potential use case. So going forward, you got like artificial intelligence. So that's the other offering that Microsoft provides on that platform. So you might be familiar with, there's over 25 kind of services, APIs available. So it imitates kind of human behavior, speech analysis of images, text, etc. And these are kind of extracted away in a service provided by the fact that Microsoft has created all these algorithms, set them behind an API, which you then can, of course, can leverage. So the best way to do this, or at least, you know, I can't explain all of the models out there, but just let's try one with face recognition. So I'll feed an image into this application, and then I will feed that image basically to 3 types of services. So the only Microsoft Cognitive API, but I also integrate or consume the APIs available on the AWS with Recognition Service and the Google Vision API. So let me expand this a bit. Load the image. So I'll take one of myself. And in this case, I moderated the picture, so I give me a little bit of blonde hair. And then I'm serving this up to AWS. So basically in AWS, I set up the service, set up some with security details, and then I downloaded or at least got a NuGet package in my application, and then I was able to call out the application. And what you see is age range, some of the emotions that are available. This is kind of the outcome of this API. Then if I click on the Microsoft one, I get a different set of results at back. So their service is of course different, its scores are different, but it does something like with gender, male, as you can see, and age. Give some other aspects of this picture as well. So it's a different type of outcome, but you can combine those outcomes if you like in a certain application. And then you get Google, who's a little bit less sophisticated, doesn't do age and gender, but does give you some of the other traits of this picture. So in a nutshell, this is how you could leverage some of these services. Okay, so very short and sweet. Basically, considerations with AI are kind of similar to machine learning. It depends on your workloads. The workloads, because all the services that are available on the Azure platform are skewed, as in they have a free tier all the way up to a premium tier. So it depends on how much requests per second or minute you're going to feed into your API that basically gives you result bed. So you could even go into throttling type of issues if you choose a lower skew. Then, of course, with those skewing, you also have to deal with costs. And there's also certain appliance or compliance applies as well, because if you work with, for instance, pictures, then this can act to, you got to be compliant in that aspect maybe as well. And the other thing that applies for AI and for also ML is, again, the business case and the value you're going to derive from it. Now, discuss both of the, you know, like a little bit in a nutshell, the machine learning and the AI aspects of the Microsoft platform. What's interesting is there's a lot of innovation going on. If you're familiar with Build, they always do this Imagine Cup. So that's Microsoft's yearly student startup competition. And last year, Easy Glucose won. So that's a less intrusive way to measure your glucose level type of thing if you're a diabetic. So there's a device, which is a mobile phone. They adjusted it with an extra camera addition. You put it in front of your eye, and then it scans your eye and basically determines if you need to inject yourself with insulin instead of puncture yourself and do the blood test. It's less intrusive. Last year's winner, this year's winner was Team Hollow. They kind of created an application with some of the therapy practice applied to mental patients. And then again, they used some Azure Analytics and AI services as well. And especially this year, all the 6 finalists in total, because there's 6 finalists, all had, you know, AI and machine learning type of components. And then the other thing is, if you look in this business in general, there's many reports out there with predictions about how this market will evolve. But, you know, I've seen quite some numbers and they're staggering. So they're like, you know, by 2025, so it's a couple of years from now, it's going to be hit almost $400 billion. So that's quite a market out there. So going forward, so of course this is an integration conference, and you know we have to deal with integration services. So they're depicted here. They're kind of out of the box. You got the logic app, you got your API management, event grid. So you saw a session of Dan today, and also yesterday there's service bus. So those are kind of your tools of the trade within cloud integration. You can even add some functions and Azure Data Factory to it. Not going to in depth, but I want to take out one. Most of you are familiar with Logic App, and it allows you to connect with all kinds of services. It's Azure platform, it's SaaS applications, even on-premise, as depicted in this picture. And the interesting thing is that it also allows you to even build smarter integrations, like serverless type of integration with any out of the box that you can create. So that you can leverage those cognitive services available on the Azure platform just through your Logic App. So potentially you have some kind of workflow you want to run, but you want to leverage those services. So you can connect to cognitive services, but even a machine learning model can be exposed as an endpoint, which you subsequently can consume in a Logic App. So, and this is done, you know, you've seen probably Twitter demos in the past, right? So you can easily tap into social media and get some data out, serve it up to cognitive services, put it in a SQL database and show it, you know, directly for a Power BI dashboard. Also push it to storage for later experimenting if you're interested in some kind of data out inside of Logic App. So let's take an example of, you know, what situation you're currently in with the COVID-19. Let's say you want to derive all the content, or at least all the tweets around this, so you can ingest that data into your Logic App, feed it up to sentiment analysis available in Azure. So you basically serve up the Twitter text, and then you can push those Twitter details and sentiment score to, let's say, that SQL database or to storage, whatever you want. So this is a run, so I'm not going to switch to the Azure dashboard. Basically, it's pretty simple. You connect to Twitter, authorizing through your account, basically. Then you serve that data to a sentiment analysis, and then subsequently you compose some of the elements to push forward. So this is just an example of what could be ingested. This is one typical run. So Logic App's multi-threaded, so you know it can consume dozens of tweets all at a time, depending on your interval. Then you basically serve the text up to the text analysis. So that's good sentiment analysis that scores it between 0 and 1. So this is kind of extremely positive, because it's almost 100% if you multiply this by 100. And then, you know, you can basically take some of those elements out of your outputs, so from your tweet, but also in sentiment score, and push this off, or at least you create a message and push that off. What's interesting here is that, you know, that text analysis API, and I've put in the link here on the bottom, is like, it's completely described on all the data centers where it's available. And this is where you can look into some of the methods that, in this case, the cognitive services text basically provides for you, and how you could leverage, what parameters to use, etc. You can even, as you can see, download the API definition as well. So it's pretty nifty, and it's well documented as well. Okay, so monitoring. So I'm not going to talk about monitoring tools, but in general, you already heard me talking about some of the use cases, right? So the office is that you start monitoring what happens, right? Some of the innovations when it comes to a patient with diabetes, that you start to basically monitor what the glucose levels, so that's monitoring and observing. Those are kind of use cases. And even when you tap into social media, you basically are monitoring. So I see that this monitoring has something to do with machine learning AI and even integration somehow, if you start building these types of solutions. So you start keeping track, you're doing surveillance, review. That's kind of what monitoring is in this essence. And, you know, I got a scenario in this case, and it's a pretty interesting one. This is from Ali Safi. So 2 or 3 years ago, when we had the Global Integration Bootcamp, Ali Safi, who is a premier field engineer from Microsoft in the UK, presented this type of scenario. So this is a Tollbooth scenario. So a lot of things are coming together. Basically, on a toll booth, you're monitoring all the passing cars. You take a picture of it. The picture is being pushed into an Azure Blob Storage, which subsequently raises the event like blob created, which subsequently can trigger one or multiple subscribers. So this is a completely like efficient push-push model, event-driven. But one of the functions is leveraging computer vision API and basically using the optical character recognition. It basically extracts that license plate out of it, which is then subsequently pushed as an event on Event Grid, which triggers other functions that pushes it into a Cosmos DB, maybe triggers another Azure function which stores that data into a blob storage, triggers, or at least a function is then being triggered by a logic app, which then communicates with Office 365. So this is kind of completely serverless solution. And it's actually something that Microsoft built and is available, I think, somewhere in the US on one of the toll roads. Although mind that, some of these capabilities going forward from that point 2 years ago in time now is that you can also place the computer vision more to the edge as well. So you have the edge device already doing something else, that compute processing of finding out what the license plays, and then you can still serve that data up to your serverless solution, store it, and eventually build a client or send an email or basically give him notice that he should pay for his toll if he's not automatically registered already. Sometimes you have this displays in the American cars that they're already member of something and then they can automatically build. Okay, so I kind of want to demonstrate this as well. So I'm serving up some of the license plate blob storage. It will generate that event, blob created, which triggers a function which then calls that service API. So very simple. I'm just loading a few license plates up. They're like triggering multiple functions that call the cognitive services. And then within the text, you'll find some of the license plates. So just illustrates of what, would happen. Basically, you provide the image, the function basically serves that up as a stream to the cognitive services, which then will apply the OCR depending on the fact that I'm calling that endpoint. So again, I want to point out the documentation, in this case of the computer vision API. Like I said, all the data center that's available, then I'm using the OCR. So this describes this type of function and what I need to give as a request and etc. And again, you can download this API. It's pretty straightforward what you can use these endpoints for. Again, the endpoint is displayed in the below. So going through AI in a one-on-one kind of type of fashion, straightforward, same as machine learning monitoring. It's kind of, they have a correlation together because usually monitoring drives AI and ML type solution. I think I've pointed that out in some of the scenarios that what happens currently in the market. There's a lot of potential in these capabilities, but all has to do with the fact that, things that already happened in the past, which you can accumulate it in data, are happening in the present and you want to do some prediction, like predictive maintenance, for instance, also gathering a lot of data, let's say for a wind turbine, right? It's running and running and you just start gathering the telemetry and then based on certain predictions, when there needs to be maintenance. And I think monitoring is a driver for AI and ML or data-driven solutions. And the other thing I think is when you see me presenting about it, I'm not a data scientist, but you do see that integration is a part of this. Integration is an element in this, and this is where you consume APIs, you can create this workflow to create a type of solution. And the other interesting thing is that Azure, in general, allows you to do experimentation. You can have free tiers of the AI. You can use ML Studio pretty much for free. And the barrier is pretty low to start experimenting with it and get familiar with the technology if you're not there already. The other thing, though, is although it's fun, I think it's fun, but don't forget the bigger picture. In the end of the day, if you do this for a customer, you have to find and drive towards a business case and the added value. Not just, it's good for fun learning, but I want to stress out that the business case and value in the end is very important. And then again, as an integrator, you might already do this today, gathering data or ingesting data and pushing it somewhere in a general data store or data lake. Maybe you leverage Data Factory or some of the other capabilities, or you work with functions to do data ingestion. But this is something that is, maybe in your work today, or potentially could be projects that you do tomorrow with regards to AI and ML. So there's some resources. There's, I write for InfoQ. I've written about this topic as well, with regards also to some of the Amazon offerings. You got the Azure AI platform, ML resources. Some of the middleware Fridays in the past, we digged in a little bit about this topic. So me and Ken usually did the middleware Fridays. He more from the Power Platform aspect, where there's also capabilities of leveraging AI when, for instance, submitting an expense, and then have OCR depending on what the amount is. There's edX courses, there's on-demand Pluralsight courses. And again, I've also put this link in, and basically this describes all the Cognitive Services API, all the methods, their parameters, etc., etc. So it's really very useful information if you want to get familiar with one of the 25 or over 25 APIs, Cognitive Service APIs that are available in on the Azure platform. So that's it. So I'm almost at the end, or kind of on the end, before we can do a little bit of Q&A. So you got my Twitter handle, it's GitHub, where sometimes I put some stuff on. There's my coded email as well. So, or even LinkedIn, if you like, you can find me there too. If you're doing these projects and you'd like to discuss this with me, please do reach out. Maybe we can do some chatting, or we can do some brainstorming, or some other aspects you'd like to learn about, this field and topic. I find it very interesting, although I'm not doing that day to day. Sometimes I come across a project where I do Azure machine learning and AI aspects to it. So it's a very interesting field. So with that, that's my session. I'd really like to thank you for attending this session and, attending this. And hope you enjoyed the remote so far and going forward. And, perhaps when all this blows over and we're in good health, we potentially could do this next year. Okay, let's see if there are questions.
Yeah, would indeed be fun if we can do it next year again, but maybe live. I mean,
Yeah,
we like this experience, but well, how we're doing it this year. But
in person as well.
Yeah, exactly. So indeed, yeah, there has been one question. Did you find it yourself as well?
Yes, what do you think about 5G network integrated with AI and ML? Yeah, that's interesting, because then you get more to the edge devices. So this could be Azure Stack Edge. Second. So the Azure Stack X, or those are the kind of devices you can set up in the field. So those are very interesting in, let's say, healthcare situations. And that's where you also, on the Azure Stack Edge, you find applications or services on Azure, but then particularly on that box. Then on the other end, still, 5G would be interesting if you want to serve a quite substantial amount of data in remote areas where they might still have 5G coverage. So it's a little bit of latency, but it also depends on how much data you want to push centrally to the cloud or not. So I hope this would answer the question. Let's see, I see accepted.
Yeah, is there anything else on the list? All right. Oh, one came through. Yeah, 1 second. It should pop up now in the accepted window.
Which platform would you prefer for pure AI ML? Yeah, so you get Google, Amazon, and Azure. Yeah, so if it comes to modeling, it depends a bit. So they all support open source type of framework like TensorFlow, PyTorch. There's some out there. When it comes to raw processing power with machine learning, so module optimization, it's like that Google, for instance, has its own hardware and chips. So you definitely can use that kind of platform if you
Yes, sorry, there was a lot of background noise. I don't know where it came from. Yeah, okay, no, that wasn't.
If you see Google, they got a lot of investments in raw processing power with their, graphical processors and stuff. So that kind of chipset. Amazon and Azure are pretty much on par with their technologies around data, AI, and ML, especially the AI demo. You saw that the cognitive services from Microsoft and Azure are not that different from each other. It's more Google that's lagging behind in that aspect. So I think each got its pros and cons with regards to their offerings.
Which is often the case with all the different technologies, of course, which makes sense. Yeah, yes. Yeah, well, let's see. We should wrap up pretty quickly, but let's just take another question.
Sure, if there's
and
one.
After that, indeed, there will still be one open question, but maybe you can take that offline.
Yeah, the AI financial users. Yeah, so those are more like the bots and stuff. So in Holland, they do advertise with applications that have bots, and it's like, yeah, bots are better in doing trading than humans can. So you already see that there are, behind those bots, there are already algorithms, machine learning. And then I think even what we call flits trading, or at least like very low latency trading, that's already fed up by, it's already gone through substantial models as well. So there's definitely an uptake in that too. But in total, I think in all the kinds of verticals, you will see AI and ML coming back, because otherwise, how can you predict a $400 billion US market, by 2025? So.
True. Yeah, indeed. Thank you. Well, like I said, yeah, there is one more question in the pending section, but well, we have to stop the broadcast for this session, so maybe you can take that one offline. Yeah, question from Vivek. He said.
Yeah, IT and ML. Yeah, they're married in together. I think I've showed that as well.
Yeah, true. Yeah. Okay. That's fine. Yeah. So yeah, thanks again for another session at Integrate, Steef-Jan.
Short and sweet, but I think I managed in 30 minutes. So.
Cove.co